In this video, we will be learning how to graph quadratic functions. We need to remember that the standard form for a quadratic is ax squared plus bx plus c. Now, a cannot be 0 because if we have no x squared term, we no longer have a quadratic. So, let's look at a basic quadratic. What we're going to do is let a be 1, b be 0, and c be 0. This gives us y equals x squared. How are we going to graph this? Right now, let's use a table, but by the end of the video, we will have a much more sophisticated way of graphing quadratics. So, if we put -2 into our equation, we get out 4. -1 becomes 1. 0 squared is 0. 1 squared is 1. And 2 squared becomes 4. Plotting these points, we can see that our curve is going to look like this. So that is your basic quadratic, also called a parabola. Now, we will define the vertex as either the minimum point or the maximum point for our parabola, depending on if the parabola opens upwards or downwards. Now, it turns out that standard form does not really tell us a lot about how to graph quadratics. So, we must come up with an easier form. In order to do this, we need to complete the square. So let's take an example. f of x equals x squared minus 2x plus 3. Now, remember, to complete the square, we must take the first two terms, and then we must take that b term, so in this case it's minus 2x. We need to divide it by 2 and square it. So -2 divided by 2 becomes -1, squared becomes 1. So we'll add that inside the parentheses. Now, since we can't change the function, what we need to do is subtract 1 outside the parentheses, so we have a net change of 0. So we're not changing anything because overall all we're doing is adding 0. Which is the additive identity, so we're not changing anything. Now, our next step is to factor the x squared minus 2x plus 1. So that factors as x minus 1 squared, and then we simplify the outside and we get plus 2. We have now completed the square, and we will define our term inside the parentheses as h, and our term outside the parentheses as k. This is our standard graphing form for quadratics. We'll have f of x equals a parentheses x minus h quantity squared plus k. In this example, a is equal to 1, h is equal to 1, and k is equal to 2. Let's take this form, and we see that hk becomes the new vertex. And since our a term is positive, we'll open upwards. Our shape remains the same because there's no scaling factor in this example. Now, the more complicated examples are when a is not equal to 1. So, f of x equals 2x squared plus 4x plus 3 has an a term that's equal to 2. So, in order to complete the square on this function, we first need to factor out our 2. And then we need to determine what we can add inside, and then in turn subtract outside those parentheses, so we get a perfect square. So we need to take that term, divide it by 2, and square it. So 2 divided by 2 is 1, squared becomes 1. So we will add 1 to the inside. But since we have 2 times that entire quantity, we actually in total are adding 2. So outside of the parentheses, we will need to subtract 2. So here we have that. Now we're ready to factor. We get 2 times x plus 1 quantity squared, and outside the parentheses we simplify to 1. There's our h, there's our k, and here is our scaling factor. That's the a when it's not equal to 1. How do we incorporate this into our graph? Let's take a look. So first, let's remember our transformations. Let's step away from the example for a moment and just look at our normal x squared function, our original quadratic. So there that is graphed. We graphed it earlier in this video. And what we're going to do is just see what happens when we move right by h. Now, it doesn't really matter what h is. We'll assume it's positive for this example. So if we do x minus h, we're going to move right. Let's just say h is right there. Boom. We have the same graph, just shifted right by h. Now, we'll do a scaling term in here. So remember, with transformations, if we multiply the whole function by a constant, by a scalar, we are going to stretch vertically. And in a parabola, this looks like this. So if a is greater than 1, it's going to actually make our parabola skinnier because it's stretching it longitudinally, up and down. And if it's between 0 and 1, what will happen is it will make it kind of fatter. It'll smush it towards the x-axis, if you want to picture it that way. Our final move here is to add k, so it doesn't really matter what k is. We'll just say k is right there, and we can move the parabola up. So that's our process when we see these quadratics in our f of x equals hk form. So let's get back to our example. So our first step is to use our h, and we know already that our hk is going to give us our vertex, but let's go step by step. So we're going to move left 1 first. Now we've got to scale vertically by a factor of 2. So we're going to get skinnier. There's that a term. Now we've got to move up 1. And our vertex, as we would expect, because we have a +1 in the h position, we know that our h is going to be -1. Remember that h is opposite what we would expect, and our k is +1. And there's our vertex right there. Now, another thing that we need to add into this is a does not have to be greater than 0. We can have a -a, and what will happen then is what we're doing is flipping our entire parabola over the x-axis. So here we're going to move left, and then we're going to flip in the x-axis and then scale, and then finally move up 1. So that'll get us to the same place, but it's going to be an inverted parabola. So this is a downward facing parabola. Alright, so let's look at an example. F of x equals 2x squared minus 12x plus 23. If I asked you to graph that, your first step should be to complete the square. We need to get it into a form where we can graph, where we can graph our function. So let's factor out a 2, and then we're ready to take the middle term, divide it by 2, square it, and add it. But we have to be careful when we add it on the inside. It'll be -6 divided by 2 is 3, squared is 9, but we're actually adding 18 because there's that 2 multiplied by everything in the parentheses. So we have to make sure we subtract 18, not 9, from the outside. So here we go. There's our 9, there's our -18. After some simplification, we can factor that term in parentheses, and we get 2 quantity x plus 3 squared plus 5. So, how are we going to graph this? Well, let's find the vertex first. We're at -3, 5. So, in order to get there, we need to move left 3. Then we have a scaling factor here, so we're going to scale by 2, so that's going to get narrower. And then we need to move up 5. There we go. So that's what f of x equals 2x squared minus 12x plus 23 is going to look like. And it makes sense that our a term is positive, so we're opening upwards. Here's another example. Let's graph f of x equals minus x squared minus 4x plus 4. So again, we're going to begin to complete the square. Factoring out a -1 gives us minus quantity x squared plus 4x plus 4. Now we need to take 4 divide by 2, square it, add it on the inside, and then we need to take the opposite of it on the outside. So now when we add 4 on the inside, we're actually subtracting 4 because there's a minus outside the parentheses. So that means we need to add 4 outside the parentheses. There we go. We always have to make sure we undo what we're doing inside the parentheses. So here we get f of x equals negative quantity x plus 2 squared plus 8. Now that we've done a few of these, we can do the fast version of graphing, where we identify the vertex. Here we know it's going to be opening down because of the negative sign, and we know that we're not scaling vertically because the a term is -1, which just means that we need to flip it upside down. So this should have our original quadratic shape, but needs to open downwards because we have a -a. Now that we're good at graphing quadratics, let's find a quick way to find the minimum and maximum values. So as we've seen from our previous examples, if we have an upward opening parabola, the vertex will be the minimum point, and if we have a downward opening parabola, our vertex will be the maximum point. So we are going to take our original quadratic form, remember the one that we didn't really like to use for graphing, and we're going to just use, in general terms, our A, B, and C, and we're going to come up with the general form of H and K, of our new vertex. So we need to complete the square with this. And it might look a little scary with the A, B, and C, but it's all the same steps that we've already done. So first thing we need to do is factor out an A. So we will get A times quantity x squared plus B over AX plus C. Now that B over A looks a little weird, but if you can picture distributing that A back inside, you'll see that we'll get back to our original. So we did factor that correctly. Now our next step is to take that middle term, divide it by 2, and square it. And then we have to add that on the inside, and then we're going to have to subtract A times that term on the outside. So here we go. I know it looks scary, but we've got, on the inside there, we've got x squared plus b over ax plus b over a over 2 squared. That's exactly what we said we were going to do. Take that, divide it by 2, and square it. So that's all we've done. And then we have our plus c and minus a times that the quantity b over a over 2 squared. So that's the same steps we've done. It just looks a little different with letters substituting in for our numbers here, doing it with variables. So now, after a little simplification, we can turn our b over a over 2 quantity squared into b squared over 4a squared. So that's all I've done. Now in our final step, we're going to factor that term in the parentheses and just multiply through, kind of simplify a little bit that last term at the end there. We can cancel out an a from the numerator and the denominator. So now we've got, once I put parentheses around it, we've got our h term and we've got our k term. Now it doesn't look as pretty with our variables, but it will be very useful in just a moment. So let's get back to our original term. So we could write the vertex just like this, as a ordered pair of negative b over 2a, comma c minus b squared over 4a. So that's just coming from our h and k that we did in the previous examples, but now we can do it for any generic form as long as we know what a and b are. There's our equation for our vertex. So, as we saw before, our vertex is a minimum if a is bigger than 0. If our parabola is opening upwards, we will have a minimum. And it will be a maximum if a is less than 0, where we have a downward facing parabola. So, using the vertex in a general form like this allows us to find mins and maxes very quickly. So let's look at an example. Let's find the maximum or the minimum of f of x equals x squared plus 4x. So, once we identify that a is 1, b is 4, and c is 0, we can use our vertex formula, negative b over 2a, comma c minus b squared over 4a, and just plug in our values to find out what the vertex is. So here I've done that, and after some simplification, we get down to -2, -4. So our vertex for this parabola is at -2, -4. And since a is 1, it's positive, it's bigger than 0, so we have an upward opening parabola, which means that -2, -4 is a minimum value. Let's look at another example. Again, we're going to find the maximum or the minimum of this function. So f of x equals minus 2x squared plus 4x minus 5. Here we see that a is -2, b is 4, and c is -5. In this example, we're just going to compute the x component of the vertex. Here's another way to solve these. So remember, the x component of that vertex is just -b over 2a. So let's find out what that is. So substituting in with our b and a from this example, we get down to 1. X is equal to 1 for our vertex. Now, if we don't feel like memorizing the second part, the y component of the vertex, we can just evaluate the function at that x value, and it will give us the output of that function will be the min or the max of the parabola. So here we're going to put in 1. F of 1 is going to be equal to that. As we simplify, we're going to get something a little nicer. So it turns out that f of 1 is equal to -3. So since the a value is -2, it's negative, it's less than 0, we know that we're opening downwards, so we have a maximum value. So the maximum value of this function is -3.